Hello students, in our previous video, we learnt about the physical properties of metals and non-metals. Today, let us learn about the chemical properties of metals and non-metals. Do you know the chemical property of any element is the way it behaves during reactions? Let us explore chemical property with the help of some experiments. First, let's start with how they react with oxygen. But before moving further, let me tell you, these experiments must be conducted under proper supervision. For this experiment, we have to take few metals like sodium, potassium, magnesium, copper, aluminium, silver, gold and platinum, one burner and pair of tongs. First of all, let's keep metal samples in a dish. Now we hold one of the samples, say magnesium, with a pair of tongs and try burning it over the flame of the burner. We repeat the same process with the other metal samples like copper, aluminium, iron, etc. one by one. Then we collect the product formed, if any, and observe the reactions. Here we observe that metals like sodium and potassium burns with an explosion when exposed to air. That is, they react vigorously with oxygen present in the air. While some metals like magnesium, aluminium and copper require heating to react with oxygen. Metals like gold and silver do not burn, do not react with oxygen even on heating. So now the question is that whether all metals burn? And if burn, what do they form after burning? Let's see. When we burn magnesium, we see that it produces dazzling white light and white powder, which is nothing but magnesium oxide. When we burn copper wire, it combines with oxygen and forms black copper oxide. Similarly, on burning, aluminium reacts with oxygen and forms aluminium oxide, which is also called alumina. We also observe that no matter how much we heat gold, silver or platinum, they do not react with oxygen, thus do not form their oxides. In general, we can say that almost all metals combine with oxygen to form metal oxides on burning. So the answer to our question is every metal does not burn, but some metals burn and form respective oxides after burning. Students, let us now see how non-metals react with air. Just like metals, non-metals also form their oxides on reaction with oxygen. For example, when sulfur reacts with oxygen, it forms sulfur dioxide. Let us understand this with an activity. First of all, we take sulfur powder in deflagrating spoon. Now, we burn sulfur powder on a burner. We will observe that it first melts and then starts burning to form sulfur dioxide. Similarly, when non-metals like carbon reacts with oxygen, it forms carbon dioxide. And nitrogen on reaction with oxygen forms nitrogen dioxide. Students, have you thought what is the nature of metal and non-metal oxides so far? Whether they are acidic or basic? Let us answer this question. For that, let's take magnesium oxide powder, which was formed when we burnt magnesium in the presence of oxygen. Now, dissolve it in water and test the resultant solution with both red and blue litmus paper. Is the solution acidic or basic? We observe that magnesium oxide solution changes red litmus paper to blue and does not change the color of blue litmus paper, indicating that it is basic in nature. Thus, we can say that aqueous solution of magnesium oxide is basic in nature. In general, we can say that some metallic oxides get dissolved in water and form bases. And that is why that aqueous solution turns red litmus paper blue. But some metal oxides such as zinc oxide, lead oxide, tin oxide, etc. show both acidic as well as basic behavior. So when such oxides react with acids, they behave like a base, while when they react with bases, they behave like acids. Such metal oxides which react with both acids as well as bases to produce salts and water are known as amphoteric oxides. For example, aluminium oxide and zinc oxide both react with acid and base to give salt and water. Now students, recall our activity with sulfur. the product formed was sulfur dioxide gas. Now we dissolve sulfur dioxide in water by immersing the spoon in a beaker filled with water. Then we cover the beaker with a lid so that the gas does not escape. This trapped gas now dissolves in water. Then we test this solution with blue and red litmus paper. Is sulfur dioxide gas acidic or basic? Yes, you have rightly observed. It is acidic as it turns blue litmus paper to red and does not show any change with red litmus paper. Sulfur dioxide, when dissolved in water, forms sulfuric acid, which is why it turns red litmus paper blue. Similarly, when we dissolve nitrogen dioxide in water, it forms nitric acid, and when we dissolve carbon dioxide in water, it forms carbonic acid. Thus, to generalize, we can say that most of the non-metallic oxides are acidic in nature. But when we burn carbon in insufficient air, or we can say in insufficient oxygen, it forms carbon monoxide, which is neutral oxide. So students, we have learned that metals and non-metals both forms oxides on heating with oxygen. Metallic oxides are basic or amphoteric, while non-metallic oxides are acidic or neutral. Thus, students, we have answered some questions like whether all metals burn, what do they form after burning, what is the nature of oxide form, acidic or basic. But students, there are some more questions that arise from our activity, like at what rate metals burn and react with oxygen? What flame color do we observe when metal is burning? How does metal surface appear after burning? And are the products soluble in water? We will answer all these questions in our next video.